अब स्टूडेंट्स कुछ बात स्टार्ट करेंगे about the second generation of Ethernet, and that generation, after all the changes that we have spoken about, was called as fast Ethernet. Students, in the 1990s, we made a big jump by creating what we call as the fast Ethernet, which was able to support 100 megabits per second. So a straight jump from 10 megabits per second to a new standard which was able to support 100 megabits per second. Students, in this particular case, we wanted to not touch the max sublayer, but students, there were certain elements of the standard Ethernet that were related to the transmission speed. In order to increase the transmission speed from 10 megabits per second to 100 megabits per second, we needed to make some changes to those particular features that were related to transmission speed. Now, students, there were some goals of the fast Ethernet. In order to jump from standard to fast Ethernet, there were some goals that were set by the different institutions that worked towards this particular advancement. The first goal was to upgrade the data rate to, of course, 100 megabits per second. The second one was to make it compatible with standard Ethernet. And the reason for that compatibility is so that all the different technologies that are already using standard Ethernet, they don't have to move to a completely different technology. They can simply upgrade and move from using the same hardware, mostly, move from the standard Ethernet to the fast Ethernet. So the third goal was to keep the same 48-bit addressing scheme, and I'll tell you why this was a goal in later discussions. And then students to keep the same frame format, because there was a lot of work that was already done on that frame format. Students, to be able to handle 100 megabits of data, several changes were made at the physical layer. Students, we also added new features in there. A feature that we are going to be talking about in later discussions is of auto negotiation. Students, there was nothing like that in the previous version of standard Ethernet. And auto negotiation, it actually allowed the source and the destination to discuss the mode of operation, to discuss the data rate that they are going to be supporting before they actually start transmitting the data. So students, it allowed different devices, incompatible devices, to also use fast Ethernet to actually exchange data using the Ethernet technology. Students, such new features and the changes that we are going to be talking about starting from the next slide, they allowed the data rate to be increased from 10 megabits per second to 100 megabits per second in the case of fast Ethernet. Students, as you can see, the first change that we made was in the encoding in the case of fast Ethernet. Students, हम लोगों ने standard Ethernet के केस में आपने देखा था कि for all the implementations we used Manchester encoding. Students, Manchester encoding, it needed a 200 megabaud bandwidth for a data rate of 100 megabits per second, and therefore this was not a choice for a medium such as twisted pair cable. So students, for this particular reason, in the case of fast Ethernet, we looked into some alternative technologies. Students, the first implementation of fast Ethernet, which is 100 base TX, it used two pairs of twisted pair cable. Students, it can be UTP or it can be STP. And so this TX out here, it represents the twisted pair. Students, for this implementation, we used the MLT3 encoding scheme. And the reason for that was its bandwidth performance. Students, since MLT3 is not a self-synchronous line code, so what we do is we use 4B/5B block coding to provide the synchronization in this case by preventing the occurrence of a long sequence of zeros and ones. So this combination that you see out here, it is made up of 4B/5B encoder and MLT3 encoder to accomplish a data rate of 100 megabits per second in 100 base TX. Students, in the case of 100 base FX, FX is for the fiber. It uses two pairs of fiber optic cable. And students, in this case, fiber optic can handle the high bandwidth requirement by using simple encoding scheme. So we again reverted back to NRZ-I encoder. In this case, And once again, for synchronization, we used a combination of NRZ-I with 4B, 5B encoder, because we know from our previous discussion, you have to remember that it's important that NRZ-I has got a bit synchronization issue for long sequence of zeros or ones, and therefore we are using 4B, 5B in this case as well. Students, then you have higher technologies. In the case of 100 base TX, it can provide a data rate of 100 megabits per second, but it required the use of 5 UTP or STP cables, and this was not cost effective, and therefore we developed a new standard which is called as 100 base T4. And in the case of 100 base T4, we used category 3 or higher UTP, and this implementation used 4 pairs of UTP for transmitting 100 megabits per second that was required for fast Ethernet. Student, the encoding that we use in this particular case was 8B by 6T encoder to support 100 megabits per second. So students, to quickly summarize, we have got 3 basic implementations of fast Ethernet. The first one is called 100 base TX. The medium use is STP, shielded twisted pair. The medium length is a maximum of 100 meters before we are required to use repeaters. The wires are 2, and coding use is a combination of 4B, 5B, and MLT3. 100 base FX, which uses fiber medium, 2 pairs, 185 meters is the max length. We use 2 fibers, 4B, 5B, and a combination of NRZ-I. And the last one is 100 base T4. Students, we use UTP or 4 pairs of UTP. In this case, maximum length is again 100 meters, and we use 2 8B 6T encoders in this particular case.